we are going to talk in the first section about what's new, obviously. Last one of these was about 6 months ago. In that time period, I think we've done 2 Aeron releases, 143 and 144. So we're going to talk about some of the big bits in that, as well as some of the features that are going to come up in subsequent releases. So.
Sure. So one of the biggest features, I guess, and one of the most voted over the last couple of years is what we call response channels. This is latest hot of the press from 144 release. This feature is also the first one that comes with a warranty label, experimental. That's the first time the Aeron ever done experimental feature. It's just for us to reserve we might potentially kind of do work on it, and therefore we changes on the API and maybe parameter names and stuff like that. But what it is, response channels. You probably, if you're a user of Aeron, know that whenever you want to talk from point A to point B, you need a publication subscription on the other side. However, you cannot talk in reverse. You cannot respond to that, right? You need another pair to go back. The problem with setting up that is quite painful usually because the, let's say, server side of it has to know the address of the receiver. And in static configuration, it's easy. You can just specify that. In dynamic configurations like clusters and archives, that needs to be provided. It means client has to send this information over. The problem there is that it doesn't work in the scenarios where, for example, network address translation is used, because the address of the source not going to match the address that the destination sees. So because there is like address translation in between. So to address that, which happens, for example, if you use Docker in non-host networking mode and other places, we're building a feature whereby we're changing the way the response channel is set up, and we automating this. I think we have a slide with examples. It's much easier for me to talk to you by showing the example. So what you see here, when you create the setup is a bit different. So it's a very specific order in which things have to be created. First, we create a subscription to the remote side. So this is a client side. And the subscription has a new control mode. You've probably seen control mode dynamic and manual for MDCs. This is a special response mode. So it has to say, okay, there is a server port, there's somebody listening to that, and I'm connecting to the stream. And on the publication side, it uses the information from the subscription to pass this information so that through the response correlation ID parameter, so that the media driver connects the two. Now, if you go to the next one, the server side, listening side is very easy. It's basically standard Aeron subscription, nothing special. However, it needs to handle multiple incoming connections. And you see here there are 2 handles passed, handle connect and disconnect. This is the unavailable image hooks that we have in Aeron. And so what we need to do there, I think we have a slide for it as well, is that whenever image is incoming, we need to create a response publication. So imagine you have a server listening to multiple clients. It needs to respond to all of them. So for every new incoming connection, it has to set up publication. And it's doing it again by setting up control mode response and connecting this response to an incoming image. So there is a coupling between all the pieces. So the client's publication that sends the data in is recorded in this response correlation ID. So this image is recorded. And it also remembers the image to publication mapping. Why? Because whenever you receive the data from the client, you probably want to respond it. And because there are potentially multiple clients, you need to disambiguate and choose to which client you're going to respond. I mean, of course, you can like broadcast and respond to all of them, but in normal scenario, it will be like pub-sub type of scenario where you respond to a particular client. So you need to know that this image corresponds to that publication. And on disconnect, we just basically just remove that and forget about it. So there's a lot of this magic. We're going to put it, and we already started putting it in. It's not in the release, but it's coming in 145 in the archive and potentially cluster, where we're going to simplify some of the, not just only configuration, but essentially make it work with scenarios like network address translation and things. So the main thing, so this is the code side of things. I think James has pretty pictures, and it's
yeah, so it's quite a lot to take in. So we tried to draw a pretty picture to try and represent like a before and after. So as Dimitri said, you've got this kind of, I've got various numbers here that I'll go through one by one. On the server side, and this is happening in cluster, it's happening in archive, it's happening everywhere you want to like establish bi-directional communication. So the first thing you do on the kind of acceptor side is you create a kind of well-known subscription and you give it a well-known port. the client comes along, wants to connect, it's creating a subscription over there. In this instance, it's got to give it its address. It's got to know where it's listening, so that it can construct a publication and send a message to the cluster to say, I want to connect, and this is where I'm listening. That message gets sent in. The server then establishes a publication to be able to get messages back, at which point you've got bidirectional communication. That's what happens, and it works fine. It's great. You're able to get bidirectional communication, but it creates some complexities in configuration and some network topologies that you just can't do that kind of communication in. So the two main changes, or three main changes that are going on here is kind of number one, from an application protocol perspective, you're not having to send a message in to establish that response channel. That's happening based on the configuration that Dimitro showed earlier. Instead of the initiator creating a channel for the server to listen to and so that it can connect back, it's not having to do that. It's actually using MDC to be able to create the connection to the server, so the server that can then start sending data back. So hopefully it's going to give us easier configuration overall and kind of more network topologies that Aeron Transport's are ultimately going to be able to be used on. Cool. The other thing, there are a few people in this room that this is applied to, and where some of these feature requests have come from. The way that we handle messages that exceed the overrun window. So for anyone who's seen Aeron Stat recently, you'll recognize Aeron counters at the bottom with subscription positions, receive positions. Those are tracking kind of what window of data the receiver has got. It will receive like the contiguous receive position that represents how much data is ready, and then where you've consumed up to. And the earliest consumer kind of plus the receiver window defines a window of data that the subscriber is kind of ready to receive. And so in a scenario where you've got multiple receivers, you've got these kind of the multicast groups, these kind of multi-flow control strategies. You may have receivers at different rates and therefore defining different receiver windows. And you've got different configuration to decide what you do with the slower consumers, whether you hold up the stream for them or whether you let them overrun. And so this example particularly is good in a scenario where you've got a slower consumer, it's had a blip, it's taken longer to process a message, that kind of thing. Before, if it received a message beyond its receiver window, that message would be dropped on the floor, at which point, at the point that it kind of gets there, it has to do NACS, or it has to drop the connection and reconnect in order to establish. What the major change which we've made now is that instead of dropping that message, we now kind of allow an additional buffering on the subscription side that ultimately means that even if you do take a blip in the consumption, that data will still be there because it's been received, and ultimately, there was no sense in dropping it really, like up to a certain point. So we're using half a term length of buffer on the subscriber side, which kind of matches quite nicely with what we're doing on the publication side with a publication buffer. So hopefully this should be making kind of those kind of slightly less performant consumers of data a bit more robust in the scenarios where there are bursts of traffic or where it takes a pause.
Yeah, and given the default term lengths for UDP 16 megs, so half of it would be 8 megs versus receive window default 128 kilobytes. So we're talking massive amounts of slack we allow for this to kind of keep the slow ones still hanging and potentially recovering, especially if it's transitive issues like GC, for example, or some sort of other pause.
Yeah, worth saying this is not a fix for a persistently slow consumer that's not going to keep up. For those kind of scenarios, we'd recommend using archive and got more rate adaptation patterns rather than using that 8 meg buffer if it's just going to be, if it just can't keep up with the stream.
Oh yes, DNS. Quick show of hands who had DNS issues. Nice. DNS issues with Aeron. So, okay, great. Now, hopefully, they all will be gone. So, the way Aeron uses DNS name resolution, every time you specify an endpoint, so creating publication subscription, you need to give it. You can give it an address. In this case, there is no name resolution. But if you give it like a host name, it needs to be resolved. Up to 144, what was happening is that the conductor thread would have to resolve the DNS name. And in some environments, as we probably all know, it can take seconds or tens of seconds. We've seen reports of over 30-second DNS name resolution. That means that the conductor thread will be stalled. And if conductor is stalled, it's not doing some important things like updating counters, which affects flow control and kind of creates a havoc across the things. Not to say even that the clients, the Aeron clients, will think that the driver is dead because the driver is not updating its keep alive counter because it's just busy doing DNS. So how we solved it? So we decided to do a resolution asynchronously. In 144, we added a background thread that basically we offload the name resolution to. So the conductor will be happily chugging along. The very moment it encounters like add publication at subscription, it will throw it off the back to the background thread just for the name resolution. Once that comes back, it will continue adding the resource. So resource adding the subscription or publication will not get faster. I mean, it's still bound by the DNS name, but the driver conductor thread is not bound by this time. And that hopefully will solve quite a bunch of issues for, I think, for all of you. If you've been using Aeron, that's one of the big ones.
Yeah, this is a kind of, well, DNS has always been an issue, but it's particularly, we're seeing more commonality on the people who have DNS infrastructure that they don't necessarily control, particularly in the kind of cloud environments. DNS queries can easily take kind of a few seconds, and when that was happening on the conductor, it was causing some strange behavior. So we're hoping that those go away. We can't fix DNS for you, but at least we fixed how Aeron handles it.
One other use case where it helps is address resolution. So if you're on the cloud and your VMs are migrated, the address needs to be re-resolved, and that typically happens coordinated across the fleet. So you have multiple machines to resolve the address at the same time, so there will be a lot of requests to resolve. And previously they would just queue one after another, so the post will be ginormous. Now they can be thrown off to the background thread for it, or multiple actually. At least on Java side, you can configure many, or even plug in your custom thread pool if you want. You can completely control the process.
We've done well. I mean, most of our feature requests come from either stuff that we want to do strategically or stuff that comes from clients. But there's also stuff that comes from support. So we've made a plethora of debuggability improvements, and these are just a few.
Named clients is one of the ones that requested quite a lot. Just to clarify, we're talking about Aeron client, so Aeron.java. Now you can specify a name in it, and it will show up in the Aeron starts output like this, and there is a little name equals value, so you could distinguish which clients are connected. There are other clients like cluster clients and archive clients that currently don't have this feature in, because this is a media driver local, the other ones are remote, but it's something we consider doing in the future. It seems to be a common use case for these things. Your favorite one, logging?
Yeah, so for those of you who haven't played around with it, Aeron Agent is kind of Aeron's answer to logging. As you will know, for those of you who started up a media driver, it's very quiet. That is kind of by design. Logging takes time, and that it costs in terms of performance. So we have Aeron Agent, which kind of weaves into the bytecode logging statements. So you can have logging with zero cost if you don't want it. We've made big changes in terms of how we log that out, so that it's more useful, more readable, rather than being a kind of wall of text that only Dimitro can understand. The rest of us can have a look at it now as well.
Yeah, and we've also done more to observability, so not just for us to support, but also for you. And one of the interesting features that came over the last 2 releases is snapshot duration tracking. Probably most of you or people who use cluster know about snapshots, and snapshots might be costly. And you probably want to know how long the snapshot take. In 143, we added an overall snapshot duration counter. So when you take a snapshot, you will see time it took the last snapshot, how much actually it's a max counter. So it never goes down. It will be only growing up if the snapshots take time. And then we added in 144 set of counters per service. So you can quantify, like if you're running multi-service scenarios, you know which service is taking time. We're also exposing quite a lot of information in terms of leadership terms ID, election counter, how many elections the system done, and a bunch of others. So there's like more rich output, especially in the cluster. Helps us with support, and hopefully helps you to also troubleshoot type of things, where to look at. We also print more configuration. There's this flag, Aeron print configuration equals true. It used to be media driver only, and now it's for all components. Once you throw it in, like archive and cluster will spit out its guts, so we'll show the config values it was started with, which also helps us support.
One of the other things we added was some enhancements to cluster backup. This is the component that can connect to the cluster, kind of do a live replay of the log directly to a remote archive, as well as transferring snapshots. That's got a new functionality to be able to kind of just seed from the latest point, so from the snapshot and beyond, rather than having to go back to the beginning. That kind of speeds up this kind of backup scenario where you want to seed enough data on another node to be able to start up a cluster. We've also added similar functionality in cluster standby. This is the premium component that allows you to run like warm replicas of the clustered services. So in a scenario where you want to kind of invoke DR or replace a node, which is the new feature we added, you can do that with kind of very little downtime, kind of very low RTO. And this is the kind of one of the other things that we've been working on as a bit of a theme of development, allowing for these kind of rolling upgrade scenarios where you've got a 3-node cluster, you've got version 1 of your logic running in all 3 of those nodes, and you want to upgrade into version 2 with the kind of minimal amount of kind of blip in your latency, in your kind of responsiveness and availability. So we've been adding features, we've been leveraging features such as kind of end of stream flags to be able to, at the point that you've upgraded your 2 nodes, your 2 follower nodes, you've restarted them, they don't have an impact, and now you're wanting to restart the leader node. Kind of this is the point where graceful leader step down cuts in. At that point, we've been making changes to make it as fast as possible for that to happen. So a new leader is elected. This is showing a client sending in data 100,000 messages a second and recording how long it takes to get a response. This is showing the latency of how long it took to get the response in a kind of cloud-based environment. And we see that kind of red dotted line is where we kill the leader. And then you see the message that at the point that you kill the leader, it takes the longest time to actually receive a response for, because you have to wait for the new leader to be elected. So we see in this version of the failover test, it taking about a second to establish a new leader. We've been working on it. We've got that down a bit further in the latest version. We're kind of about half that to be able to kind of do this rolling upgrade with kind of minimal fuss. Plus, you've got another event here, which is where we restart that node again and kind of bring it up, so we get that full upgrade story. And then this is what's coming up, or at least some of it. One of the things we're looking to do is drop support for JDK 8 and 11. We're doing a consultation with our support customers around that. As Dimitri mentioned, we're looking at kind of using response channels across the rest of our kind of stack in archive and in cluster to simplify configuration there. Anything that comes up from our customers, we'll consider it on our kind of roadmap if we think it's going to make life easier for you and kind of other Aeron customers. We're working on a new premium feature so to stop you running out of disk when you're using cluster, to do the kind of cleaning up of old log data and old snapshot data. And last but not least, Aeron Sequencer, which Dave will talk to you about in a second.